Welcome to Part 6 of the Android Interview Series 2024, focusing on Jetpack Compose. This series is designed to help you master key concepts for Android interviews, covering everything from basics to advanced topics. In this episode, we'll explore Jetpack Compose, Android's modern toolkit for building native UI. Whether you're preparing for interviews or aiming to upgrade your skills, this guide will walk you through the essentials, practical examples, and best practices. Let's dive in and discover how Jetpack Compose is changing the way developers build Android interfaces, making UI development faster, easier, and more maintainable. Jetpack Compose is Android's recommended toolkit for building native UI. It simplifies UI development by using a declarative programming model. Instead of manipulating UI elements imperatively, you describe your interface with composable functions. This approach reduces boilerplate code, minimizes errors, and makes your codebase easier to maintain. Jetpack Compose is designed to work seamlessly with Android Studio, offering live previews and powerful tools that streamline the development process. By focusing on composables, developers can create reusable UI components, customize them with parameters, and build flexible layouts efficiently. Traditional Android UI development relies on XML layouts and imperative code, where you define the UI in XML and update it programmatically as the state changes. Jetpack Compose, however, uses a declarative approach. You specify what the UI should look like based on the current state, and Compose automatically updates the UI when the state changes. This shift eliminates manual intervention, reduces code duplication, and enhances reusability. With composable functions, you can easily create and reuse UI components, making development more efficient and less error-prone. Composable function is the fundamental building block in Jetpack Compose. By marking a function with the @composable annotation, you enable Compose to track and manage the UI it represents. Composable functions define pieces of UI in a declarative way, automatically handling updates whenever the underlying data or state changes. This makes UI development more predictable and maintainable. For example, you can create a greeting composable that displays a personalized message, and Compose will update it whenever the name parameter changes. Let's look at a simple composable function example. The greeting function takes a name parameter and displays a text message. By using the @composable annotation, Jetpack Compose knows to manage this UI element and update it whenever the name changes. This approach allows you to build dynamic, interactive interfaces with minimal code. Composable functions can be combined, nested, and reused throughout your app, making UI development modular and scalable. Jetpack Compose has a unique lifecycle, similar to traditional Android, but tailored for its declarative, reactive nature. The lifecycle consists of 3 main phases: composition, recomposition, and disposal. During composition, UI elements are created for the first time. Recomposition occurs when the state changes, updating only the affected composables. Disposal removes composables that are no longer needed, cleaning up resources and ensuring efficient memory management. Understanding this lifecycle is crucial for building responsive and efficient UIs. Composition phase is where Jetpack Compose builds the UI tree by evaluating composable functions and creating UI elements. This phase happens once for a given part of the UI, unless it needs to be recreated. Once composed, the UI stays on the screen until it's updated or removed. This initial setup establishes the view structure and prepares the UI for dynamic updates based on state changes. Efficient composition ensures that your app loads quickly and displays the correct initial layout. Recomposition is the process where Jetpack Compose updates the UI in response to state changes. Only the functions affected by the state changes are reevaluated, ensuring minimal work and optimal performance. If no state changes occur, Compose will not recompose. This selective updating keeps the UI in sync with the underlying data and improves responsiveness. By tracking dependencies, Compose ensures that only relevant parts of the UI are refreshed, reducing unnecessary computations. Disposal phase occurs when a composable goes out of scope or is replaced by another composable. Jetpack Compose cleans up resources associated with the composable, such as canceling coroutines, releasing listeners, or disposing of state objects. If disposable effect cleanup code is defined, Compose executes it to ensure no resources are left hanging. Proper disposal prevents memory leaks and keeps your app running smoothly, especially when navigating between screens or removing components. Modifiers are powerful tools in Jetpack Compose, used to modify the appearance, behavior, and layout of composable functions. They add properties like padding, size, background, click actions, and layout adjustments without altering the composable itself. Modifiers are stateless, chainable, and highly reusable, allowing you to define them once and apply them to multiple composables. This flexibility makes it easy to build complex UI behaviors and maintain consistency across your app. Jetpack Compose offers several types of modifiers: layout, appearance, behavior, animation, and custom. Layout modifiers control size, padding, alignment, and positioning. Appearance modifiers adjust background, border, opacity, and shadow. Behavior modifiers add interactivity, such as click handling and gestures. Animation modifiers enable smooth transitions and effects. Custom modifiers let you define extension functions for frequently used combinations. By chaining modifiers, you can create flexible and dynamic UI elements tailored to your app's needs. Creating responsive layouts is essential for modern Android apps. Jetpack Compose makes this easy with modifier functions like fill max width, fill max size, weight, and wrap content size. These allow composables to adapt to available screen space. Constraint layout enables complex responsive layouts by defining constraints between elements. Box with constraints lets you access screen constraints and create conditional layouts based on size or orientation. Window size class categorizes screen sizes, making it simple to switch layouts for different device types. Jetpack Compose handles orientation changes automatically by recomposing the UI based on the new configuration. Composable functions defining the layout and behavior are reevaluated with the updated orientation, allowing the UI to adapt seamlessly. This automatic handling reduces the need for manual intervention and ensures a consistent user experience across different device orientations. Recomposition in Jetpack Compose updates parts of the UI when there is a change in state. When a state variable changes, Compose identifies the composables that depend on that state and reruns only those, updating the UI accordingly. This targeted approach minimizes the work needed to keep the UI in sync with the underlying data, improving performance and responsiveness. State represents data that can change over time, and that Compose uses to update the UI when it changes. By managing state effectively, you enable the UI to automatically respond to changes in underlying data. Compose offers tools for both local and shared state management, making it easy to build interactive and dynamic interfaces. Local state is managed within a single composable function, typically used for UI elements that don't need to share their state. It's created using remember and mutable state of, which retain values across recompositions. Shared state is moved up to a parent component, making it easier to manage across different parts of the UI. This approach improves reusability and separation of concerns. State hoisting is a design pattern in Jetpack Compose where state is moved out of a composable function and into its parent. This makes the state shared between composables, allowing for better reusability, testing, and separation of concerns. By hoisting state, you can manage it centrally and pass it down as needed, simplifying complex UI interactions. Remember function in Jetpack Compose is used to store a value across recompositions, allowing it to persist without resetting every time the composable function is recomposed. Compose caches the value during the initial composition and reuses it during recomposition. If the composable leaves the composition, the value is cleared. This is useful for maintaining state within a composable. Remember savable works like remember, but preserves its state across configuration changes, such as screen rotations. It saves values in the bundle of the saved instance state, enabling restoration after configuration changes. This is especially useful for UI elements like text fields that need to retain state when the device orientation changes. Mutable state is an observable data holder that allows composables to react to changes in state automatically. When the value of a mutable state object changes, Compose triggers a recomposition for any composables that read that state, updating the UI to reflect the new data. Mutable state is typically created using mutable state of, which holds the initial value and updates whenever it changes. Derived state is used to create a new state based on one or more existing states. The derived state of function computes values based on other states, updating only when the underlying states change. This approach helps optimize performance by avoiding unnecessary recompositions and recalculations, ensuring that derived values are always up to date. Side effects refer to any change in the app state that occurs outside the scope of a composable function. They should be executed in a way that respects the composable lifecycle to avoid unexpected behaviors. Side effects ensure that actions occur only when necessary, keeping the UI efficient and consistent. Jetpack Compose provides several tools for managing side effects, such as launched effect, disposable effect, and remember coroutine scope. Launch effect is used to run suspend functions within the lifecycle of a composable. It triggers a coroutine when the composable enters the composition, making it ideal for tasks like fetching data or handling side effects based on changes in state. The key parameter identifies the launch effect instance and prevents unnecessary recompositions. If the key changes, Compose executes the side effect again. Disposable effect is used for side effects that require setup and cleanup, and the composable enters and exits the composition. It's often used to manage resources that need explicit cleanup, like registering or unregistering listeners. Disposable effect ties resource management directly to the composable's lifecycle, preventing memory leaks and ensuring resources are cleaned up when no longer needed. Remember coroutine scope provides a coroutine scope tied to the composable's lifecycle. It's useful when you need a coroutine to start based on a user action, such as a button click. The scope ensures the coroutine cancels if the composable leaves the composition, maintaining efficient resource management and preventing leaks. Remember updated state keeps an updated reference to a value within long-lived or side effect composables, like launched effect or disposable effect, without restarting them when the value changes. It pins the latest value, ensuring ongoing effects can access it without triggering recompositions or rerunning the effect. This is useful for callbacks or lambdas that may change over time. Side effect function runs non-suspendable side effects during each recomposition. It allows you to perform actions that don't require cleanup, but need to execute whenever a specific recomposition happens. Examples include logging, debugging, or updating external objects not tied to Compose's lifecycle. Snapshot state list and snapshot state map are special collections in Jetpack Compose designed to work efficiently with Compose's state system. These collections are observable, meaning that when their content changes, they trigger recomposition in any composables that depend on them. They are ideal for managing lists and maps, ensuring the UI updates automatically as data changes. Snapshot flow converts state changes within the Compose snapshot system into a Kotlin flow. It allows you to observe changes to Compose state values in a coroutine-based flow format, which can be collected and transformed asynchronously. This is useful for reacting to state changes in a non-composable function or combining, debouncing, throttling, or filtering state updates in a coroutine context. Produce state is used to convert external state, such as data from a network or database, into Compose state. It launches a coroutine that updates the state as necessary, making it useful for managing state derived from external sources. This enables you to fetch data synchronously and feed it directly into your composable state, ensuring the UI remains responsive and up-to-date. Composition local provides a mechanism for passing data down through the composition implicitly, without needing to pass it through every composable function. This is useful for frequently used data, such as theme information or configuration settings. Composition local is similar to dependency injection, but tailored for Compose's hierarchy, allowing composables to access ambient data globally within a certain scope. There are different types of composition local providers: composition local of and static composition local of. Composition local of creates a composition local with a default or fallback value, ideal for frequently changing data like dynamic themes or user preferences. Static composition local of is optimized for static values that do not change during recomposition, such as singleton dependencies or app-wide configurations. Jetpack Compose also provides predefined composition local objects for common scenarios. You can manage navigation in Jetpack Compose using composition local. By providing navigation-related data through composition local, you enable composables to access navigation functions and state without passing them explicitly. This approach simplifies navigation logic and keeps your codebase clean and modular, especially in large apps with complex navigation flows. Jetpack Compose allows dynamic themes switching with the help of composition local. By providing theme data through composition local, you can easily switch themes at runtime and ensure all composables update accordingly. This is particularly useful for supporting dark mode, custom themes, or user preferences, enhancing the user experience and app flexibility. Managing authenticated state of a user can be streamlined using composition local. By providing authentication state through composition local, you allow composables to access user information and authentication status globally. This approach simplifies state management and ensures consistent access to authentication data across the app. Delegation is a design pattern that allows a class to delegate responsibilities to another object or class. In Jetpack Compose, delegation is especially useful for state management. The by keyword facilitates delegation, making code concise and readable. Property delegation allows a property to be managed by another object, often used with mutable state of, or remember to delegate state management and trigger recompositions when the property value changes. Jetpack Compose offers several optimization techniques. Using remember to cache values across recompositions, remember savable for preserving values across configuration changes, isolating state-dependent parts of the UI within smaller composable functions, and using launched effect for side effects that need to occur only once or when certain keys change. Derived state of avoids redundant calculations, and lazy column and lazy row render only visible items, conserving memory and improving performance. Managing resources efficiently is crucial in Jetpack Compose. Using disposable effect for setup and cleanup ensures that resources are freed when the composable leaves the composition. Stable data and unique keys and lists help Compose avoid unnecessary recompositions, and Animate has state functions provide smooth animations with minimal recompositions. These practices keep your app responsive and resource efficient. Managing state using ViewModel and live data is recommended for handling state across lifecycle events, such as screen rotations or when state needs to persist beyond the lifecycle of a composable. ViewModel provides a central place for state management, and live data ensures that UI updates automatically as data changes. This approach is robust and scalable for complex apps. Stateflow is another powerful tool for managing state in Jetpack Compose. By combining ViewModel with Stateflow, you can handle state updates reactively and ensure the UI remains in sync with the underlying data. Stateflow is ideal for scenarios where you need to observe and react to continuous state changes, providing a modern, coroutine-based approach to state management. Recomposition refers to deferring the composition of UI elements until they are actually needed or visible on the screen. This is especially useful for handling large collections, like lists or grids, by composing only the items currently in view. Lazy composition optimizes performance and memory usage, minimizing the number of composable functions composed at any given time. Composition is the process where a composable function re-executes to reflect changes in the underlying state. Compose tracks state reads within a composable, and any changes trigger recomposition. Skippable recomposition is a performance optimization that prevents recomposition when dependencies haven't changed. Compose can skip recomposing parts of the UI if the values are stable, improving efficiency. Jetpack Compose provides several composable functions for relative positioning, such as box, row, column, and constraint layout. Box allows overlapping composables, row and column position items horizontally or vertically, and modifier offset gives precise control over position. Constraint layout offers advanced positioning features, similar to traditional XML layouts, enabling flexible and complex UI arrangements. Jetpack Compose revolutionizes Android UI development with its declarative approach, composable functions, and powerful state management tools. By understanding the lifecycle, modifiers, responsive layouts, and optimization techniques, you can build efficient, maintainable, and dynamic interfaces. Whether you're preparing for interviews or building production apps, mastering Jetpack Compose will set you apart as a modern Android developer. For more in-depth learning, explore the rest of the Android interview series, including topics like Kotlin basics, coroutines, flows, and Android architecture. Follow experts like Anatom Murthy and Pro Android Dev for the latest insights and practical tips. Stay updated with Medium's recommended posts and community discussions to keep your skills sharp and ready for any interview or project.